All right, so go ahead and put number one. Number one on the practice test says, identify each pair of angles named below as either adjacent or vertical angles. As adjacent or vertical angles. There are 4 angles. So what we're going to do for number one is you're going to put A, B, C, and D. And instead of writing the angles, I'll just have you write the words adjacent or vertical every time. So we will call this one A. It wants to know if GDA and CDE are adjacent or vertical angles. So the way that we look at an angle when it's given with 3 letters, we start at G, we go to D, we go to A. So we're talking about this angle right there, which looks like it's a right angle. I'm not 100% sure it's a right angle. It looks like it is, but I'll just highlight it as that angle right now. And then we have angle CDE. CDE is this angle right there. Would I say those are vertical or adjacent, Frank? They're vertical. So for A, we can write vertical. Remember, vertical angles are angles that open up in opposite directions when 2 lines cross. And so the 2 lines we're talking about here are this line and that line. Looks like they're both right angles. Will every vertical angle be congruent to its other vertical angle? Are vertical angles always congruent? What do you think?
Yeah.
Yeah, they are. When 2 lines cross, the angles on opposite sides will always be the same size. Vertical angles are the opposite angles, and the reason they're special is because they are always congruent to each other. Okay, so that will always be true. They'll always be the same size. Will adjacent angles always be the same size? No, just because 2 angles are next to each other does not necessarily mean they're the same size. Okay, moving on to part B. Now we've got angle ADB, A to D to B is this acute angle up here. And then angle FDE. FDE is this acute angle right there. Are they vertical or adjacent, Addison? Also vertical. Yeah. They're opposite from one another and looks like they're the same size. Well, turns out they are because they're vertical. All right, so that was B. Now we're moving on to C. BDC and CDE. BDC, BDC is this angle right here. And CDE, CDE is that angle here that we've had before. Vertical or adjacent, Jude?
Adjacent.
These are adjacent. They're what? Next to. That's what it means to be adjacent. That's right. If 2 angles are adjacent, that means they share a common side. These do. They are definitely not the same size either. So I know they're not vertical. They are adjacent. Yeah, nothing special about adjacent angles. They're just next to each other. Unless they form a right angle or a 180-degree angle, then I might be able to find out what they are. The last one here, D, says ADF and EDF. ADF, A to D to F is this obtuse angle right here. And then EDF is this angle here. What do you think, Caden? Are they vertical or adjacent? Adjacent, that's right. Now, if you look at all 4 of these angles, or angle pairs, all of them have the letter D in the middle. That's because when you write an angle, you have to put its vertex in the middle, and all of them are going to have the same vertex of D in this diagram. Okay. Now, when they said for the first one, GDA, they could have also said angle ADG, and that's going to be the exact same one. You can flip the last and the first 2 letters around. You just can't change the middle letter. Otherwise, it's going to be a completely different angle. The vertex has to be in the middle. All right, number 2. Select each figure in which the value of X is 35. There is 1, 2, 3. So on your paper, you can put A, B, and C, because we're going to need to find X in all three of these. The first one's pretty simple. What does a straight line measure? 180. So I can just take 180 minus 155, and that will tell me what angle X has to be equal to. What'd you get, Maddox? 25. Okay, that's not 35, so I don't want to check that box, but I did have to find out what it is first. By the way, what do we call two angles that add up to 180 degrees? Jude?
Supplementary.
Supplementary. Nice. A vocab word we're definitely going to need to know for our test Friday. In fact, there are 4 different types of angles we've talked about. We've talked about adjacent and vertical, and then we talked about complementary and supplementary. That's obviously where we're headed right here. Two angles that add up to 90 degrees then are called complementary. And so I can take 90 minus 55 to figure out what this angle X has to be. Maddie Yentez, what's 90 minus 55? 35. All right. So I'm going to check that box, or in your case, you could probably just put a circle around the B because that one does equal 35. And then for part C here, it gets a little bit more complicated because there's 2 X's. There's an X on one angle, there's an X on, it's actually a 3X on the other angle. So what we're going to need to do is really just ignore this ray right here and just look at the other 2 angles. If they're sitting on a straight line, what does that tell you they have to add up to? 180. Okay, so I'm going to have to, instead of just subtracting from 180, I'm going to have to write an equation. My equation is going to say this. X plus the 3X plus 40 angle. Remember, you don't need to use parentheses like they did. Those 2 angles are going to add up to equal 180 degrees because they are sitting on a straight line and they are supplementary to each other. Then I can start solving. And it's been a while, it's been a little bit, but we've done this before, not only earlier this chapter, earlier in the year when we had our equations chapter. Lucas, what will 1X and 3X give me? 4X. Okay, so I have 4X plus 40 equals 180. Every time I solve a step, the equation gets a little bit nicer. Parker, do I want to get rid of the 4 or the 40 first? The 40, that's right. How do I get rid of a plus 40? That's right. And Parker, what will 180 minus 40 be? 140. 140. So now I have 4X equals 140. You guys tracking with this so far? Just solving the equation here. Now we have to get rid of the 4. That 4 is not being added or subtracted like the other one was, the 40 was. This is being multiplied to the X. And the opposite of multiplying is dividing. And what is 140 divided by 4? Addison? 35. It is 35. Excellent. So X is 35. And that's what we're looking for it to be. So we can circle C as well. So of the 3 diagrams we had here, the 3 figures we had, 2 of them gave us X equals 35, and the other one was X equals 25. You guys ready for me to move on? All right, number 3. For number 3, we have 4 pairs of angles. So for number 3, what we'll do is we'll write A, B, C, and D. And then we're going to write for A, B, C, and D either complementary, supplementary, or neither. Now, Jude reminded us that complementary angles add to 90 degrees. And we all collectively said that supplementary angles add to 180 degrees. So if I get something else, that's when I would say neither. Anything other than those 2. So for the first one, we'll call this one the first one, A. Sierra, can you tell me what 134 plus 36 is? I'm looking for 90 or 180. If it's not that, then it's going to be neither. $170. Okay, so put 100. Well, I guess for A, we'll just write 170 degrees right there, and then we can just put neither. That way I can see what it added up to. On your test, I'm going to ask you to do the same thing. Show me what they were, and then put the neither. Okay, this one's B. The two angles in diagram B, the angles here are 78 and 12. Lainey, can you tell me what 78 plus 12 is? 90. Lainey, what do we call two angles that add up to 90 degrees? Complementary, that's right. So I'm okay with you guys abbreviating that. COMP would be the abbreviation for complementary. Now we'll move on to angle pairs for C. Addison Stumpf, what is 67 plus 23? $90 degrees, awesome. And remember what Lainey just said, we write two angles that are 90 degrees. What do we write for those? Are they complementary, supplementary, or neither? Complementary, yep. So for C, we can write 90 degrees, complementary. And let's check out D. They look like they're sitting on a straight line. Let's find out for sure. Hunter, what's 98 plus 82? It is 180. Awesome. And Hunter, what do we call two angles that add up to 180 degrees? Supplementary. That's right. So we can abbreviate that SUPP. Sup. You think that's funny? All right. We good with number 3? Yeah. Let's move on to number 4. Number 4 says, find the value of X. We're going to do it the same way we did in number 2 for that last one. They are going to add, these two angles are going to add to what angle measurement? Maddox? 180. They sit on a straight line. We would say that they are supplementary if they sit on a straight line and add to 180 degrees, because two angles that add to 180 are always supplementary. So because I know they add to 180, the equation I'm going to write is X plus 35 plus the 4X angle has to equal 180. Whitney, what does 1X and 4X add up to? All right, so the first step is to always simplify. If there's more than one variable term or more than one constant term on the same side of the equal sign, you should simplify them or combine those terms together first. So now we have 5X plus 35 equals 180. Whitney, that was too easy. I'm going to give you another question. Do I want to get rid of the 5 in the 5X term or the 35 next? Excellent. What's going to help me get rid of a plus 35? Perfect. So I write minus 35. I do it on both sides, and that leaves me with just 5X on the left side. And Whitney, 180 minus 35 is 145. Okay. Alexis, how do I get rid of the 5 now? Divide it. Okay. It's being multiplied to the X. Can you tell me what 145 divided by 5 is? X equals 29. Nice job. All right, so there's our answer. We just have to find out what X is. By the way, that would be like the hardest problem on the test because it was a 3-step equation I had to solve. I had to combine my terms. I had to subtract 35. I had to divide by 5. Those are steps that you can do pretty easily. We've had equations like this before back in our equations chapter in section, it was chapter 3, I believe. The rest of it really isn't that difficult. I mean, think about how hard the math calculations have been. You've had to subtract from 180. You've had to subtract from 90. For quadrilaterals, you had to subtract from 360. Those are all easy math things to do, especially when you have a calculator. What you're going to have to focus on in the next 2 days is your vocab. Because I can add 67 and 23 together. But if I don't know what two angles that add to 90 degrees are called, then I'm not going to get this problem right. So I have to know the vocab in order to get it. I have to know that two angles that add up to 100, or sorry, that are sitting on a straight line are going to add to 180. I'm going to have to know that. Otherwise, I'm not going to know what to set this equation equal to. Like that's a vocab thing. I have to know that they're supplementary. I have to know that that means they add up to 180. Okay. So a lot of vocab. That's why tomorrow we're going to work on that vocab crossword puzzle. This is number 5. This is number 5. All right. So again, we're going to put A, B, and C. It wants us to classify the triangles. Now they give us a multiple choice, but you know what? I don't think we need that. I think we could do this without looking at the names of the triangles. This first triangle. So we're going to classify it by its angles and sides. That means it's either going to be an acute, right, or obtuse triangle. Let's start with that. Maddox, what do you think? Acute, right, or obtuse triangle? It is obtuse. What told you that it was going to be obtuse? There you go. If it's got an obtuse angle, it's got to be an obtuse triangle. What you can't do is look at it and say, oh, it's got an acute angle. This must be an acute triangle. Every triangle in existence has 2 acute angles. Only the ones that have 3 acute angles are acute triangles. Okay? Because if it has 1 right or 1 obtuse angle, then it's not going to be acute anymore. Now, I noticed that a lot of people on their quiz that you got back yesterday, when you're classifying triangles, only put one of the 2 classifications down. You either did just the angle one or you did just the side one. Okay? We have to have both. So obtuse is how I classify it by its angles. How do I classify this one by its sides? Is it scalene, isosceles, or equilateral? Hannah? What told you that it was isosceles? You're right. That's right. There's your spelling for isosceles. Isosceles is what it looks like. Okay. Now, Hannah just said that there are 2 sides that are the same. That's what it means to be isosceles. However, you can also see there's 2 angles that are the same. That'll always be true. If there are 2 angles that are the same, 2 sides will be the same, and therefore it's isosceles. Okay. You can even see the red tick marks there for the sides to show you those 2 sides are the same. Obtuse, isosceles. Speaking of the quiz, for those of you that want to retake the quiz, it is today during your SLT period. This will certainly help you get a better score on that. But yeah, make sure when you're classifying your triangles, you get both a side and an angle classification. Let's move on to example B. Let's classify it by its angles first. Is this triangle acute, right, or obtuse? What do you think, Natalie? Acute. What told you that it was acute? All 3 angles are less than 90. Perfect. Okay. All right. So let's go to the side classification. Scalene, isosceles, or equilateral. Does it look like any of the angles are the same? So none of the sides will be the same. What do we call a triangle that has no congruent sides? Jude? Scalene. This one's acute, scalene. By the way, that's more vocab, isn't it? Adjacent, vertical, so complementary, supplementary. Now we've got acute, right, obtuse. We got scalene, isosceles, equilateral. You can throw equiangular in there as well. That's one of the classifications you can label by an angle, is equiangular. Speaking of which, this triangle here would be equiangular, wouldn't it? You have 3 equal angles, equiangular, right? You could also say it's acute. I would accept acute, or I would accept equiangular for its angle classification. It is definitely an acute triangle. So if you put that it's acute, I would not count off for that. But it's a little bit more special than the previous one, because the previous one, although it did have 3 acute angles, these are all the same. They're all 60. Okay. So you could say acute, or you could say equiangular. You still need a side classification. What do we call a triangle with 3 equal angles and therefore 3 equal sides? Hannah? Equilateral. So you got to give me one of the either acute or equiangular, and then you have to give me equilateral for its side classification. You could just remember that every equilateral triangle is also going to be equiangular, and you could just put the 2 equals down, equilateral and equiangular. All right, number 6. Number 6 says the measurements or measures of 2 angles in a triangle are given below. Find the measure of the 3rd angle in decimal form. Well, what do the 3 angles of a triangle add up to? 180. So I know that these two angles plus the third one has to add up to 180. So I can start by taking 180 and subtracting away whatever these two angles add up to. Ella, what does a 28.5 and 104.25 angle going to add to? $132.75. Okay. Now, Ella, do you know how to use your previous answer button on your calculator?
Yeah.
Okay. Would you type in 180 minus, and then that previous answer of 132.75? That way you don't have to type it in again. What do you get? 47.25. Now, because it's an angle measurement and it says what is the measure of that angle, go ahead and put a degree symbol up there so we have it labeled. That third angle has to be 47.25. Now that we know all three of the angles, it doesn't ask us to classify this triangle, but we could. Are any of the angles the same? So none of the sides will be the same. Therefore, a triangle with no congruent sides is called scalene. This would be scalene. Are any of the angles 90 or above?
Yes.
Yes. Is it obtuse or right? Obtuse. So without even a picture of the triangle, just as three angles, we could tell that it's an obtuse scalene triangle. Number 7. Which of the following statements are always true? Takes us back to yesterday's lesson. A rectangle is a rhombus. Is that always true? No, it is not. That was not true. Now, they're in the same family, but they're not the same shape. They have different definitions. Is a rectangle always a parallelogram? Yes. In fact, the parallelograms, like the grandfather of all those shapes, here's our diagram from yesterday, right? You've got the three different families, the trapezoid family, the kite family, and then the parallelogram family. Within the parallelogram family, you have rectangles and rhombi, the plural of rhombus. And so they are related to each other, but they are not the same. To say a rectangle is a rhombus is not true. A rhombus has to have 4 equal sides and doesn't have right angles. Well, rectangle's got right angles and doesn't have to have 4 equal sides. Let's go back to our next one then. Is a rectangle a trapezoid? No, not even in the same family. Now they're in the same species of quadrilaterals, but not in the same family. The last one, a rectangle is a quadrilateral. That one's always true. A rectangle is always going to have 4 sides. Yeah, a rectangle is always going to have 4 sides. Would I be correct in saying that every square is a rectangle? Yeah, I would. Would I be correct in saying that every square is a rhombus? Yes, I would. Every square is a rhombus. In fact, it's just a rhombus with 90-degree angles, right? And a square is a rectangle with 4 equal sides. Would I be correct in saying that every rectangle is a square? No, not every rectangle is a square. A square is a more specific type of rectangle. The example I used yesterday is every girl a human? Yeah. Is every human a girl? No, I can't flip that around and say it the other way. Here's another example. Is every tulip a flower? Yes. Is every flower a tulip? No. So a tulip is a specific type of flower, the same way that a square is a specific type of rectangle. So every square is a rectangle, but I can't reverse it and say every rectangle would be a square because a square is a specific one. Okay? They're related. They are related for sure. In fact, the square is the offspring of a rectangle and a rhombus. If they had a baby, it'd be a square. All right, back to number 8 then. Number 8 says find the value of x. Now this is a 4-sided shape. So it's a quadrilateral. Would you say that this is in the kite family, the trapezoid family, or the parallelogram family? Frank? It is a trapezoid. Yeah, it only has 1 pair of parallel sides. All the members of the parallelogram family have 2 pairs of parallel sides and are also congruent on the opposite sides. And then the kite family doesn't have any parallel sides. Just the adjacent ones are congruent on this side and the adjacent ones are congruent on this side. So this is a trapezoid, and all quadrilaterals, if you add the 4 angles together, will add to what number? 360. If you've done last night's homework, you know that. So we're just going to write 360 minus, and then can someone tell me what 90 90, and 64 adds up to? Jude, do you know the answer? What is that? 254? And then Jude, can you go ahead and subtract that and tell us what the missing angle is?
116.
X is 116 degrees. Awesome. Or you could, it just says find the value of X. If it says find the value of X, just put X equals. You don't have to put, oh, is that wrong?
I got 244.
You got 244 when you added it together. Okay, let's double check this thing, because that would mean it's not 116 if that's not right. 90 and 90 makes 180. Plus 64 is 2. I'm getting 244 as well. Thank you for checking that. Oh, okay. So it is 116 then? Okay, so Jude he did the right steps and just couldn't remember what number he got when he in his calculator. Okay, so 116. That's all I just need to put. X equals 116. Now, does that make sense? 116 is an obtuse angle. Does the angle we're missing look like it's obtuse? Okay, so at least I have a chance of getting it right. Number 9. There is no number 9. There is no number 10. You can make your next problem number 11. Number 11 says, let angle 1, 2, and 3 have the following relationships. Angle 1 and 2 are acute vertical angles. I'm going to stop right there. The only way I can have vertical angles is if 2 lines cross. So I'm going to go ahead and just draw 2 lines intersecting. I could make them straighter if I just patient. Okay. There's 2 lines intersecting. They could look lots of different ways. Let angle 1 and 2 be the acute vertical angles. Well, vertical angles are opposite from each other. So the 2 acute angles that are opposite from each other are going to be angles 1 and 2. Let angle 3 be an obtuse angle that's adjacent to angle 1 and 2. So I could put angle 3 up top. I could also put angle 3 on bottom and still be adjacent to 1 and 2. It wants to know what the sum, what's that mean? Adding. What will I get when I add angles 1 and 3? So let's ignore angle 2 for a second because it just wants to know about angles 1 and 3. What will I get when I add angles 1 and 3, Alexis? That's right. I'm going to get 180 because they sit on a straight line. They're adjacent to each other, forming 180 degrees. They are said to be supplementary, and that means they are going to add to 180 degrees. Go ahead and put your degree symbol because it says what is the measure, and that means we need a degree symbol. Here's another problem that says measure, number 12. What are the measures of 2 supplementary, sorry, it doesn't say what is, it says the measures of 2 supplementary angles have a ratio of 4 to 5. What is the measure of the larger angle? We did one like this in our homework a while back, and this is how we did it. We put an X next to the 4, we put an X next to the 5. We're going to call them 4X, and we're going to call the other one 5X. That means they're still going to have a ratio of 4 to 5 because one's got a 4 in front of it, one's got a 5 in front of it. If they're supplementary, what will they add to? 180. So put a plus sign between them and set them equal to 180. That is going to help me solve X. I can figure out what factor they both have. What does 4X and 5X combine to give you? 9X. Yes, so I can't divide the 5 over, divide the 5. I can't do that because I have to combine them first. Anytime you've got more than one variable term, you have to combine them before you do anything else. So I got 9X equals 180. Now I can divide by 9. Frank? 20. Now, that is not my answer. That is just the factor that both angles have. Which angle is the larger angle? Is it the 4X or the 5X angle? The 5X. So if X equals 20, 5 times 20 is 100. The larger angle is 100 degrees. Again, if X is 20, just plug 20 in for X right there. So that larger angle is 100 degrees. Now it doesn't ask me for the smaller angle, but if you know they add up to 180, what would the smaller angle have to be? 80. All right, number 13, determine whether you can construct many, one, or no triangles. Remember, if you can only construct one triangle, it is said to be unique. And I saw, okay, so we'll just say A, B, and C, and we'll either put unique, many, or none. an isosceles triangle with side lengths 3, 8, and 8. Okay, now remember, if I give you the 3 sides of a triangle, it's not guaranteed that they will even form a triangle. I have to add the 2 smaller sides together. Here, the 2 smaller sides are what? 3 and 8. They have to be bigger than the larger side, which also happens to be an 8 because this is isosceles. Is 3 plus 8 bigger than 8?
Yes.
Of course it is. It's 11. Okay, so it can make a triangle. So the none is disqualified. It's not going to be no triangle. So the question is it unique? Or can I do many triangles that look like this? And so to remind you of this, I'm going to go back to our 7.3 notes where we talked about what makes a unique triangle. There is a side, side, side unique triangle. There's a side angle side where the angles between the 2 sides given. That's a unique triangle. Then we have, basically, if they give you 2 angles and a side, you're good. Whether the side's in the middle or if the side's somewhere next to them, that's fine. Okay, so those are the 4 ways you can make an angle, make a triangle, a unique triangle. These are the 2 I told you that you might see on the quiz or, in this case, the test. So let's go back to our problem here. An isosceles triangle with side lengths 3, 8, and 8. They gave me a side, they gave me a side, they gave me another side. I've already checked this can make a triangle. Is this unique? Yes, because a side, side, side is actually the very first type of unique triangle you have. If I give you the 3 side lengths of a triangle and say, hey, make a triangle, every one of your triangles will look exactly identical because there's only one triangle in existence like that one. Okay, so you can say one, or you could say unique for the first part, number A, letter A. Letter B, a right triangle with 2 congruent sides. Can you have a right triangle that has 2 equal sides? Yes, that means 2 angles have to be equal, right? I didn't say they both have to be 90. In fact, if one's 90, the other 2 that are equal would have to be 45 and 45. So I can make a triangle like this. They gave me the angle, and then they gave me the 2 sides. Maybe I should write the 2 sides over on this side. Keep school appropriate. So I know it's a triangle. I know it's a triangle. Do I have a SSA kind of unique triangle? I have an SAS, a sassy one. I don't have an SSA. So that means I can make, it's not unique, many triangles. Here's why. Here's a right triangle. That's also isosceles. Here's a right triangle. I ran out of room, so you just have to believe me. Here's a right triangle. That's also isosceles. Are they the exact same? No. They're similar, which we talked about Monday. They're similar, but they're not the exact same. So if I just give you 2 angles or 2 sides and an angle, you could make the triangle, your triangle is probably going to look the same. It would have to look the same as everybody else's, but it's not going to be the same size. And if it looks the same, but it's not the same size, we say it's similar, but not unique. So the answer for this one was many. And then the last one here, a scalene triangle with 2 sides, 2, 11, and 14. Now we do have an SSS. Let's check this. Do the 2 smaller sides add up to be more than the longer side? So this would be unique if it even were a triangle. It is not a triangle though. It's just 2 sides are too short. So this is going to be no triangle. Does that make sense? It doesn't meet that triangle inequality theorem that we talked about with the strings. Just flippers. They have never actually touched. Thanks. That went a lot faster than I thought. We have 1, 2, 3, 4 more problems. What we'll do is I will end it here for today. We'll finish those 4 problems tomorrow. Can you hang on to your worksheets for me? We'll turn them in tomorrow and you guys get points for that. We get out here at 25, right?
Yes.
Okay, I'll make sure. We have 5 more minutes. We might be able to finish. All right, see you guys tomorrow. All right, number 14. Classify the triangle described below. So I guess you guys also left off the same spot, yeah. Number 14 says a triangle with measures of x degrees, and 2x degrees is a blank triangle. Now, before you do any math, you should be able to tell me what kind of a triangle it is based off of its sides. There's a relationship that says if you have two equal angles, that you'll have two equal sides. And we do have two equal angles because it says X and then another X. They didn't change it to something else like a Y or a Z. So what do you call a triangle that has two congruent sides, Frank? Isosceles. So we know for a fact that this triangle has to be isosceles. So that's one way. But remember, when you classify a triangle, you use one side classification and you also use one angle classification. So I need to know if this is an acute isosceles, a right isosceles, or an obtuse isosceles. To find out what kind of angle measures it has, we know that if you add the three angles of a triangle together, it'll always equal what? 180. And so I can write that down, and you should too. And maybe I need to go off to the side because I don't think I'm going to have that room. Okay. What do you get when you combine a 1x, and a 2x together? A 4x. So we get 4x equals 180. And then 180 divided by 4. What's 180 divided by 4? Addison? 45. Okay. So if x is 45, then that means you have a 45, you have a 45-degree angle. You have another 45-degree angle. And then what's 2 times 45? 90. Okay, so we know it's isosceles. If it has a right angle, it must also be a right isosceles. So that's how we're going to classify this. This is a right isosceles triangle. You could tell it was isosceles before we did any math. And then doing the math, solving that equation for x, we can figure out this is a right isosceles with a 2 45-degree angles and a 90-degree angle. Number 15. Number 15 says, which properties are true for all rectangles? Do all rectangles have 4 congruent sides? No. No. Now, if it was a rectangle with 4 congruent sides, we'd say it's a square. But not every square, as we mentioned yesterday, not every square is a rectangle. Okay, I think we said that, every tulip is a flower, but not every flower is a tulip. A square is a specific type of rectangle, just like a tulip's a specific type of flower. Yes. Sure, you could do that. Second one says 4 right angles. Do all rectangles have 4 right angles? They do. Yep, they do. Do all rectangles have exactly 1 pair of parallel sides?
No, I mean 2.
They have 2, don't they? Yeah, it says exactly 1. What do you call a quadrilateral that has exactly 1? Not a parallelogram. A trapezoid. Yeah, a trapezoid has exactly 1 pair. So that would be the definition of a trapezoid. In a rectangle, are the opposite sides parallel? Yes. Are the opposite sides congruent? Yes. So not all 4 sides are congruent, but the ones opposite from each other will be. Okay. In fact, this definition right here is true for all parallelograms, including rectangles, squares, and rhombi. This one here is for a trapezoid. And then if it has 4 congruent sides, it could be a square or it could be a rhombus, but it's not necessarily going to be a rectangle. So the only ones that work are the 2nd, 4th, and 5th options, or as Lucas would say, B, D, and E. Okay. All right, moving on to number 16. Nope, 16 is not there. Number 17 is the next one. Number 17, I must have taken 16 off. It says, the figure shows how one path intersects the path of another to form 2 angles. Find the value of x. Well, we've done, I think this is the 3rd problem we've done on this practice test. They've given us a straight angle. What's a straight angle measure? 180. And then they give us like a couple x's somewhere in that angle. So I know that the 3x plus 12 angle added with the x degree angle has to make that straight 180 degrees. So it has to add to 180. What do you call 2 angles that add to 180 degrees? Supplementary. So it doesn't ask us to write that, but that could be on your test. Okay, it's going to be on your test tomorrow that you have to know what supplementary angles are. So let's go ahead and solve this equation. What do you get when you combine a 3x and a 1x together? A 4x. So we can say 4x plus 12 equals 180. Andrea, do I get rid of the 4 or the 12 first? And how do I get rid of the 12? Nice. Okay. Subtract 12 from both sides. And what will that give you on the right side? What's 180 minus 12? Okay. And then, Caden, how do I get rid of the 4 then? By dividing this one. Yeah, this one's being multiplied to the variable. So I'm going to do the inverse and I'm going to divide that. And Caden, can you tell me what 168 divided by 4 is? 42. That sounds about right. Anyone else get the same thing? Before we write down. Okay, I like it then. I was going to say, let's probably confirm our answers before we move on. I learned my lesson yesterday with a, I forget which class period it was. It wasn't you guys, I don't think. But we moved on and someone was like, no, I didn't get that. And everyone else agreed. After one person finally raised their hand, it's like, okay, 7 of you knew that was wrong and you didn't say anything until the one person had to raise their hand. So, all right, number 18. The angles of the construction of a wooden double gate are shown in the diagram. What is the value of X? What kind of shape are we looking at here in this diagram? It is a trapezoid, you're right. It didn't ask us to write that, but it is a trapezoid. It does have one set of parallel sides and only one set. Sorry, I was thinking like, broader than trapezoid, like this is a 4-sided shape, right? What do you call a 4-sided shape? A what? Aiden? It's a quadrilateral. Yeah, all 4-sided shapes, squares, rectangle, rhombus, parallelogram, trapezoid, kite, they're all quadrilaterals. And what's true about the 4 angle measurements in a quadrilateral? What are they always going to add up to? 360. Yeah, remember a triangle is 180, but a quadrilateral has 360. So what we'll do is we'll take 360 and we'll subtract away this 90-degree angle, that 90-degree angle, and this 76.5. Maddie Yentez, can you tell me what 90 plus 90 plus 76.5 is?
256.
Okay. And since you already have it in your calculator, you know how to use your answer button on your calculator? Come up here. I'll show you. This will save you some time. So instead of typing, oh, you cleared it. There we go. So instead of typing that in again, just do 360. And then we want to subtract that last answer, which now that it's cleared, you're not sure what it is. So see how it says A and S right there? Here's your previous answer. It subtracts away the 256 for you, 0.5, without having you to type it in again. And what do you get, Maddie? 103.5. It does say find the value of X. Anytime it says for the value of X, go ahead and put X equals. And then you said 103.5. Okay. If you want to put a degree symbol, you can, but as long as you have the X equals, because it said find the value of X, that's how you would label this problem. The degrees is just icing on the cake. If you want to write it, you can. Does it look like angle X as an obtuse angle? Because we're saying it is if we say it's 103.5. Yeah, so that checks out. It should be an obtuse angle. All right, all right, that's it. Hey, we're done. Make sure your name's on it and you can bring it up to the period 2 trim. Yes.